Hello everyone and welcome to today's webinar, Learn to Build and Deploy Machine Learning Models for Alif's Advanced Ensemble Processors. We are joined by Henrik Flodell, Director of Marketing at Alif, and Joshua Buck, Solutions Engineering at Edge Impulse. During today's webinar, if you have any questions, please post them in the Q&A box and we'll do our best to answer those as we go along, and we'll also ask Henrik and Josh the questions at the end. With that, I'll pass over to you, Henrik.
Thank you so much, Louise. Hi, everyone. Thank you for joining this webinar today. I'm going to start off by playing a little introduction video about Alif Semiconductor, because I'm not sure if you all have heard about us or what we do. So just to kind of orient you a little bit, and then I'll get right into the presentation part. Let's see here.
If you need embedded microcontrollers in the IoT space, there's one company that brings you a new family of microcontrollers and fusion processors. Alif Semiconductor. The Ensemble family offers high-performance embedded controllers designed for the edge with built-in acceleration for machine learning. Ensemble also brings you unrivaled battery life, so you get a longer life out of a much smaller battery. And Alif's unique AIPM technology enables you to constantly sense the environment, then selectively power on only what's needed to quickly finish complex tasks before going back to sleep. Scalable performance is also yours. The Ensemble family scales from a single Cortex M55 MCU real-time core, plus optional Ethos U55 neural processing unit, to dual MCU cores and dual NPUs. Then adding a Cortex A32 MPU application core, and ultimately adding another MPU core for symmetric multiprocessing. The M55 and U55 make their world debut in Alif controllers. Security is not an add-on anymore either. With the Ensemble family, bulletproof security is built right in. In fact, a super strong isolated security subsystem orchestrates protection for the entire chip, so your device and data all stay protected throughout the product's entire life cycle. Need next-level integration? It's all inside, with ample memory to support image data and machine learning operations. Complete power management, low-power peripherals, all monolithically integrated for maximum flexibility for smart applications like wearables, AI-assisted cameras, biometric access control, asset trackers, robots, or interactive interfaces. The Ensemble family from Alif Semiconductor is not a tiny step. They are a giant leap forward. To find out more, go to alifsemi.com.
All right, thank you so much for indulging me with that little kind of introduction. So what we do at Alif Semiconductor is that we provide microcontrollers and microprocessors to the general purpose market that deliver a much higher level of functional integration than the kind of legacy products from semiconductor suppliers have been able to do before. We've decided to take an approach in the design of our MCUs and MPUs and fusion processors, where we want to release families of products that straddle a very broad performance continuum and make them very scalable, both in terms of how you can deploy software to them and in terms of their footprints for being able to kind of, at assembly time of a product, select the right microcontroller, microprocessors to go into that product with compatible footprints and that software compatibility between different versions of the family. We've designed everything in the Ensemble family for long battery life. We realize that a lot of products need to run for an extended period of time on a battery. And also, even if the product is wall powered, if you kind of have that base design to be power conscious, that's good for everybody all around. And it's very difficult to kind of do something about the power consumption unless you deal with that already at the architectural stage of a product like this. We take the same approach with security. Now, I'm not going to spend a lot of time talking about the specific security features of Ensemble in this webinar, but if you go to our website, you can find a lot of information on how we have integrated a complete secure enclave into every single device in the Ensemble lineup in order to provide secure boot, secure lifecycle management, and unique device IDs and root of trust right out the gate for users of our parts. In terms of integration, we are using very advanced process technology that allows us to integrate a lot of advanced functionality as well as a lot of memory in our devices, while still maintaining very small packages kind of physically, so that we can support designs of advanced products like wearables, etc. And also we decided, because when we started planning our devices, we were talking to a lot of customers about what do they want to do in their applications going forward, 2, 3, 4 years out. What is it that they're planning on introducing in terms of design needs and the type of functions that they want to have in their applications? And a lot of the feedback we got was that even for kind of standard microcontroller edge type applications, AI and machine learning is something that's very interesting, kind of for two reasons. One is there are certain problems that really cannot be solved efficiently unless you have access to this type of technology. And also there's several customers that were telling us that they have a desire to try to improve on existing solutions by being able to more efficiently deploy machine learning on edge devices that are optimized for battery life. So we've added dedicated accelerators to the Ensemble family that makes it possible to not only do the kind of small vibration use cases, but also voice and vision type use cases in an MCU. And as we were doing that, we started looking at, the ecosystem around this type of technology in the embedded space, and who would be an excellent partner for us to work with when it comes to be able to create models, optimize models, train models, and deploy models on these kind of devices. And that led us to Edge Impulse, which we've been partnering with now for about 1.5 years. And we have just completed some very interesting integration of their platform with our Ensemble devices, which we are going to talk to you more about in the second part of this presentation. So when we talk about what we can do in the Ensemble devices, I want to just kind of give you an idea of when we say that we can optimize machine learning execution in them, what we mean by that. You see some numbers on this slide when it comes to performance improvements. These are numbers that we derived that from the first version of the silicon that we made together with ARM. We were looking at how much of an uplift in performance can we get from leveraging the accelerators, the Ethos U55 acceleration units that we put into the Ensemble silicon. ARM was expecting an uplift of upwards of 500x compared to previous generation Cortex-M class cores, but the Alif Ensemble devices delivered an 800x improvement. So we kind of outperformed ARM's estimated results by a huge margin. On the other side, if you kind of think about it, you can run the inference fast, that's great. But for an embedded device that is running on battery, on the other side of that, you have the power efficiency, because if you can finish all the math that is needed for the inference operation quick, you can put the device to sleep sooner. And when you do that, you get more battery life back for your application. So we kind of looked at that as well for some specific use cases that was based on MobileNet V2. And you can see here in the yellow box kind of some of the math that arrived at that 75x increase in power efficiency. When we run a MobileNet V2 inference on an M55 core, our M55 core in this case, running at 400 megahertz, that takes a little bit longer than half a second to complete the inference. But if I offload that network and run it on the Ethos U55, I get that inference time down to only 8 milliseconds. That means that I drop the power use over that inference period from 228 millijoules down to 3. That's a 75x reduction in the power need for that application. You think about that in terms of battery life. If you have a system that lasts for a week on a battery that is doing machine learning type operations, and you get a 75x boost to that, now you have a system that can run for more than a year on a single battery. So that is really quite a leap in terms of efficiency, both for performance and also for battery life. The things that enable this to get to this kind of efficiency uplift is a combination of the Cortex M55 cores that we're using in our system and the fact that they've been extended with helium vector instructions that allow SIMD operations for the first time in a Cortex M class device. This provides significant boost to essentially a lot of the math type operations that can be parallelized, because with SIMD you can in one cycle process up to 4 32-bit operands in parallel. And also the memory interfaces in our device are fully parallelized to be able to take advantage of this. So we can fetch an instruction and we can fetch up to 4 operands out of the TCM memory connected to the core in just that single cycle, and then perform the computation extremely fast. So you see some data on this slide on just how that helium vector extensions, how that can uplift performance across things like the DSP extensions of the core. You see in this box here some examples of that for different data types. And also an efficiency example when we look at the Dolby Atmos codec. In this case, we were upmixing from 6 channels to 7. If we index the codec's performance for an M4 core to 1, with a vectorized version of that codec running on our M55, we were able to take 64% of the work out of that upmix operation. And you can have that back either as more time to sleep to save power, or more processing capability to do other things in the application, which is really good. The second part of the equation is the Ethos U55. Alif is the first semiconductor vendor that has this micro MPU system in silicon. And this is a dedicated configurable accelerator that can offload, that you can offload CNN and RNN type workloads onto, and it will run those networks mostly without any involvement from the M55. And be able to complete the inference operations very fast. It also has built-in compression for the models themselves, meaning that the models take up less space in the firmware of the device, so that you can put more advanced capability into the model and store that in the chip at a smaller footprint. We have up to 2 of these micro MPUs in the Ensemble devices that can operate in parallel. So essentially you can run multiple networks at the same time. And you can see in this table here some of the uplift that you can expect from being able to do this offload operation of the machine learning from the MCU core to the acceleration unit. This is something that is really important if you're planning on doing a design that leverages machine learning and you want to deploy that in a small embedded system like a microcontroller. Today, there are a lot of solutions that allows you to run neural networks directly on CPU cores, but they're not really designed to be able to handle those workloads efficiently. You really want to pick a solution that you can offload that type of operation onto an accelerator that can run it and be able to finish it quickly, so that you get the instant performance, and you also get the battery life of your system into kind of that embedded envelope that you want to be in. We have run several benchmarks on our Ensemble family and the tutorials that comes with the Edge Impulse platform. This is the result for some of them. Responding to your voice is essentially a keyword spotter, and the add sight to sound is essentially a system that classifies images. It looks at pictures of forests and tries to determine if there are fire visible in those pictures to if you think about kind of a wildlife camera deployment that is supposed to warn if something like that is going on in nature. For the voice tutorial, we indexed the result of running it across all these platforms to our high performance core in the Ensemble E3 device, which was the fastest one that we tested. And you can see how it scales up depending on which other platforms that we're running this on. Even on a Raspberry Pi 4, we're significantly faster than that for this type of workload. And on the vision-based inferencing, we can run on our high-performance core up to 769 frames per second on that type of workload using Edge Impulse, which is a very good performance boost. The Ensemble devices comes in different flavors. We have 4 series of Ensembles, and they scale up depending on how many application cores are available in the system. We have single core MCU options, dual core MCU options, and then we have what we call fusion processors with either 2 MCUs and 1 MPU core, or 2 MCU and 2 MPU cores in the same device, sharing the same resources, memories, peripherals, etc. Of course, we've talked about the M55 and Ethos U55. This is the latest 32-bit MCU and MPU technology that ARM has to offer for these classes of devices that we have integrated in the Ensemble family. We are the first supplier to offer the combination of the two. We also have the very latest 32-bit MPU technology from ARM in the Cortex A32 available in the E5 and the E7 series of devices. The E1 device is configured kind of as this ultra low power base of the entire Ensemble platform, and then we layer additional execution environments on top of that you can activate when they need to perform work and need to finish that work fast. So in the dual core E3 configuration, for instance, you can have this high efficiency side of the device with the M55 core running up to 160 megahertz and a dedicated Ethos unit for that core that is 128 max wide, operating in an always on mode, collecting data from sensors and essentially making sure that the environment around whatever the device is not changing in a way that is out of the ordinary. So it kind of does all the sensing, and when it detects something that crosses a threshold, say that there is a noise, or for instance, the light turned on in the room that the device is deployed in, it can wake up the high performance side of the device, which is an M55 unit that is a little bit more than twice as fast, and an Ethos unit that is twice as wide, that will be able to process what happened and classify that in more detail extremely quickly. This has around 4x the amount of machine learning performance than the high efficiency side of the device has. And then as you go up, you have the A32 units that can run high-level operating systems like Linux, so you can offload graphical user interfaces or advanced networking or things like that on those cores, while still maintaining the ability to very efficiently run real-time applications. If we look at a 15,000-foot view of what else is in the Alif devices, the top row on this slide here outlines the application systems that you saw on the previous slide. They plug into a transactional bus, and we maintain the same bus across all of the subfamilies of the Ensemble family. This is what gives us the software compatibility. And then in addition to that, we have similar footprints across all of the series, so that you can design one PCB and you can pick whichever specific Ensemble device that you want and just deploy that as a stuffing option at manufacture time. I mentioned that we can put quite a lot of memory in our devices, and you can see on this slide that we go up to almost 14 megabytes of integrated SRAM and almost up to 6 megabytes of integrated non-volatile storage. We use MRAM in our devices, not flash technology, and that buys us several other advantages as well, with smaller page sizes for doing in-system updates and other things along those lines. We have all the standard digital interfaces that you expect in microcontrollers in the Ensemble devices, in terms of sensor interfaces, in terms of connectivity for things like USB, Ethernet, CAN options in some devices. And we also have 2 external memory expansion interfaces, octal SPI based, that you can use to expand both non-volatile as well as RAM storage. We have a dedicated imaging subsystem where we have display interfaces and camera interfaces, and we have both serial, MIPI serial and parallel versions of both in the system, as well as a GPU unit to accelerate drawing on bigger screens. And then, as I mentioned, we have a very serious security subsystem with its own secure CPU that integrates a unique device ID that you can use to establish a root of trust for the system, that has secure boot facilities, that has a lifecycle management state machine, and that also can be used to partition all the shareable resources in the system, the memory, the peripherals, etc., and allocate them exclusively or shared between the application cores. That's the firewall control portion you see on the slide here. We also have a very rich analog subsystem with Sigma Delta ADCs, SAR ADCs, and all the other analog controls that tend to be needed for interfacing with those type of sensors. And to round things out, we have a smart power management subsystem that divides all of the functionality up into 8 domains. And we have dedicated LDOs for each domain, as well as all the DC to DC conversion done internal to the device. So no additional external components needed for powering Ensemble devices. It's all done with on-chip resources. One example of this in a system, I'm going to play a little video here as well.
Maybe more people.
Let's see if I can disable the audio on it. So this is a use case that we filmed on one of our evaluation boards using a couple of different machine learning models to be able to detect. Oops. Sorry, there we go. To be able to enroll a face and to be able to detect this face when it comes into view, and to also be able to kind of tell where the user is looking. This was for a security module that was supposed to go into a screen that would be unlocked if the user looked at the screen. So you had to be able to enroll the face, you had to be able to identify the face, you had to be able to see where the user was looking. So there's a lot of machine learning models that needs to be run kind of in sequence to complete this task. As I mentioned, this is filmed on a display that is connected to one of our evaluation boards. And when this system was created, we highlighted this in a tech talk with ARM that you can find on the web. We have links to it on our website. We're essentially only using an E3 MCU for all of the functions in this particular demo. All the camera input is taken in through our camera interfaces. All the ISP needed to clean up the image, to do white balance adjustment, and to debayer the sensor data is done using the helium vector engines in one of the M55 MCU cores. We store the model in our MRAM, and we execute the model out of on-die SRAM. The complete arena and everything is done using internal resources. All the graphic buffers for the display output is also in on-chip memory. And all the overlays to render the bounding boxes and the landmark dots and all of those things are also done with internal resources. So no external memories, no external power management. And also, in order to secure this system, we don't need an external secure element or secure MCU. It's all done with the resources that already exist in the Alif device. We have these development systems available now. This is one version of it. This is a kit that Arrow stocks. Arrow is our global distribution partner, and they have this kit available from their website. This is the kit that we will be using in the second half of this presentation. This is our application kit that comes with camera module and display and a bunch of microphones and wireless connectivity built in. You can contact us if you're interested in this kit. It will be available on Arrow's website soon. We are about to send our first shipment to them. And yeah, that's kind of what I wanted to lead in with when it comes to who Alif is and what it is that we're offering to the market. I want to hand it off to Josh, who will talk you through some details on the Edge Impulse platform and show you the integration that we've completed to get all their good stuff to run on the Ensemble devices. Thank you.
Thanks, Henrik, for the information about what Alif is providing. Quite the extensive system and quite the scalable solution that y'all have. We partner with Alif. I work with Edge Impulse to help develop models and bring an ecosystem of projects that are ready to run on these devices. Edge Impulse is an online model development platform, so you can do everything from data collection, data organization, to model development, model design. You can either bring your own model and use like known architectures. We'll be going over FOMO and YOLO today. Or you can design your own boutique model with your own custom data sets. And then really what's mainly important is we're the ability to deploy onto device. So with me today, I have one of the Alif app kits that Henrik has been so kind to provide. And we'll actually do a live demo, program the board and see the inferencing run on device and see how that looks. But first, a little bit about Edge Impulse. Edge Impulse is really an integrated ML platform from data collection to deployment. It is a royalty-free business model, which is to say that your deployments are not a per charge deployment fee. There's a subscription to our enterprise features. There's a dev account that you can use to get started for free. All we need to email and a username. But mainly it's your IP, your data sets, your models stay your models. Most of our algorithms and model development is open source on GitHub. You can find that through our Edge Impulse repos. And we try to be sure to explain through our documentation pages everything that it takes to develop and design and see what it takes to get your model running on device. If you're not familiar with machine learning applications, these are basic steps that you need in order to get something running on device. Mainly, you need to have some sort of data set. So with Edge Impulse, you can either upload data from like known data sets, let's say like Coco or ImageNet or things like that, or you can go find your own data. We make it very easy to take data from the particular device and sensor that you have on your particular board. Like in this case, I'll show how to take image data from the Alif app kit. That's really important because sometimes your sensors are of different quality or different styles than what you would find in the image data sets online. But once you have that data set, the next step to develop your machine learning application is design your model and algorithm. That comes down to figuring out what kind of DSP you may apply to the image, or let's say it's microphone data for keyword spotting, or accelerometer data for motion inferencing, things like that, to the model itself. Once you've trained your model and you think you have a something decent to work with, we provide a lot of testing tools to test it against data you haven't seen before. We offer both visual analysis and audio analysis for microphone data, and then even IMU data. And then lastly, you want to be able to deploy on the device. We make it very easy to do low code to no code deployments. So today we're going to demonstrate how you can do it with kind of no code. This is a quick way to test a model on device to confirm or validate that performance that you see in the testing tools. And then we work with Alif and our partners to put the Edge Impulse SDK on it so that you can then take C++ libraries and integrate them into your own applications, because the model is typically part of something larger. And we have this arrow here that goes back to the edge device, right? From deployment back to the edge device. Once you have Edge Impulse code running on device, we make it very easy to get that data again back into it, into edgeimpulse.com, into the platform, into Studio, so that you can continuously improve your model over time. We call this active learning. Today, I'm just going to go over a few slides and then I'll do a live demo. In the data collection, we have ability for auto labeling tools. So that way you can quickly go through a bunch of images and it tracks people and objects through frames. We have integrations with scikit-learn, PyTorch, Keras, TensorFlow. All those are available as well to get in those data sets. And then we make it easy to exchange data across projects and across different portals. So if you have an organization that's doing a lot of ML applications, you can group those projects together and then even pull from your S3 buckets as well. This is a screenshot of the model design phase. Here we are creating an impulse, which is where you're taking the data from. In this case, this happens to be accelerometer data. What kind of analysis or DSP you're going to do, and then maybe you're going to do some sort of anomaly detection on it, for example. We have a number of DSP algorithms available. You can even bring your own DSP code into the platform to train a model and then eventually deploy back onto target. Again, we try to be espouse the idea of open source, so there's no black boxes. Again, the code for the DSP algorithms are online as well. It's very important to test your models once you've designed them. So we have a number of visualization tools to test out and see how things work in the real world. So here's a screenshot for a performance calibration so that we can see, let's say how a keyword spotting algorithm does with noise from a simulated environment. We try to be aware of the hardware that we're running on to give that kind of performance information. And then it allows you to tune the model, maybe change a bit of DSP code and things like that so that you can get the best performance out of your device. Lastly, we try to deploy to as many devices as possible. You can take the code as a C++ library and You know, if you compile for the Alif Ensemble series, you can run accelerated. For other targets that may not have that acceleration, you can get that library as well. Then we also offer no-code deployments, and this is a very quick way to for the website to build the model for you and to build an application so that you can flash it on there and test and see how it performs in real life. So let me dive into a demonstration. I'm going to go to edgeimpulse.com and we're going to launch an Edge Impulse project. So I'll log in here and we're going to create a new project. I'm going to call it Alif Webinar, and I will leave it as my developer account. This is the starting point for your ML journey in Edge Impulse. So back on the presentation, we talked about data collection, model training, model testing and deployment. So those are featured here on the left-hand side. And we are going to do some data acquisition from the Alif device. So let's talk about how to even get started with that. We have a documentation page for the Alif Ensemble series found at edgeimpulse.com in the documentations. You will have to install a few prerequisites, a few dependencies. First and foremost, the Edge Impulse CLI. I'm not going to go through the installation. That takes a few minutes. And then you'll need to sign up with Alif to get the security toolkit. This is how you flash and program the device. And then optionally, you can have Docker that helps out with your deployments. I have a Mac OS today. And since I'm not going to actually be compiling code on my computer, I'll be compiling into cloud and downloading the firmware. I don't need that dependency. To connect to Edge Impulse, you do need to connect your app kit to the computer. So I have mine sitting on my desk connected via the USB port. And then I've already pre-installed the firmware, but we will definitely do a firmware deployment here in a few minutes after we kind of go through some of the getting started steps in Edge Impulse. So back to the project. I'm going to connect my device so that it appears here. We have the Edge Impulse CLI installed on the machine. I'll go over and type in the command Edge Impulse daemon. And then you need to know either your password and your username, or you can use an API key like I'm going to demonstrate here from the dashboard of the project. So I'll copy this key. I'll paste it here into the terminal. And I already have Edge Impulse firmware on the device. And it's going to ask me which serial port I want to connect to. In this case, it's the second one. And now I need to give a device name. So I'm just going to call it Josh. And when the device is connected, we should see it here in the devices field. We have it green, and it tells us what kind of sensors it has on the dev kit. So microphone, camera, etc. The same firmware can run on your own custom board, by the way. Only a small bit of port to just make sure that you have the right pinouts for your sensors and things like that. So I'm going to do some data acquisition. I am going to have my camera here. I'm going to point it at myself. I'm going to hold up the board. I'm going to take some low resolution images just to kind of show off some of the different capabilities. And I am going to take a sample. So what it's doing now is it's communicating with the board and actually kicking off a data acquisition. Oops, forgot to give it a name. I am a person. Or actually, I'll do faces here for right now. And it's communicating with the board via the serial link, acquiring data from the camera, and then uploading it to edgeimpulse.com. It's going to give a prompt here and ask if I'm going to be doing image classification or object detection. In this case, I am going to do object detection. I'm going to highlight my face. And I'm going to come over here and edit this image. But first, I got to tell it it's an object detection project. There we go. Come back over to data acquisition. And in the labeling queue, I have my image. Now, remember, I took a 64 by 64 image, so it is very tiny. But I'm going to take this and I say, hey, that's a face. I'll save the label. And we can do this one or a few more times. I'll take some different resolutions as well. So here I am again. I'll take a higher resolution picture. I'll sample. I'm just uploading right now. And again, in the labeling queue, we'll have a new image, this time higher resolution, and I'll just highlight my face. So you can do this with different images, different kinds of data as well. There's for time series data, you have graphs from which you can choose windowing. If I want to do person detection, perhaps I choose and highlight the whole person. For doing like an assembly line or something on the factory floor, maybe it's product that we're trying to highlight, different kinds of products. And we can change the label as well. So maybe, instead of face, maybe it's Josh's face, or it's a wrench or a screw or things like that. But you can go through this exercise and you can choose which data sets you want to turn it into. It can either be in your test or training data sets, which is important for how your machine model works with the data. Alternatively, you can go and upload data from a computer, from websites. We do a number of different formats. So I can choose from like a training test set from before. I can just pick a picture and upload this one file. I have some projects that already have lots of data out there, and these are clonable as well. So if we head over to edgeimpulse.com again, we can see from our developer portal under projects, a number of projects that are out there that are ready to run on the Alif devices. So I'll just search for Alif. In this case, we have ones with that detect hard hats on heads, some that work with FOMO models in Yellow V5. Here's some for gesture recognition as well, keyword spotting. And today I'm just going to work with face detection and also person detection. So here I've successfully uploaded this file, and you can see now I have a new data in my queue. And this one is not labeled, so I'd have to come in here and edit the labels. And since I'm doing face detection, again, I can choose this as well. So let me go to one of these public projects. I'm going to choose this face detection project. With your developer account, you can always clone a project, and this will move it from the non-editable read-only state into an editable state. I have it here already cloned into my repo. And in this particular project, I have a number of data already taken. So here's a few from the kit itself. When I had the lights were dark, I was trying out some different images. And then of course, some of the data sets that we had seen from previous uploads. Again, it's split between a training and test set. The training set's used for model training, and the test set will be used for model testing. In Edge Impulse, we get our name from the impulse design. An impulse is really how you collect data, what kind of DSP you're going to work on, and the model itself. In this case, for this design, I'm going to just take data at 96 by 96 so I get fast inferencing. I'm not going to do any special processing. I'm just going to process the image as color. We have a number of different blocks, and then you can upload your own custom blocks as well. And then in this case, we're doing object detection. So I'll just choose that as the type of task we're going to work through. A lot of your time in Edge Impulse will be working on both the features and the model itself. The features are the pre-processing that is done before model training, before model testing. So in other words, it takes raw data of like this camera image, or let's say from one of the data sets that we have uploaded, and process it from its higher resolution to what will actually be fed to the model. So for example, you can see here we have 3 faces labeled, but when we run it through the DSP algorithm, maybe only 2 are visible at this point. You'll have to generate the features. This takes a few minutes to do, but what's important in this data set is, or in this view, is you look at your labeled data, and you can see how the processing has been done on each particular image. So we'll load up the raw sample, and you can view the feature directly, again, see how it's been squashed or skewed, things like that. Since this data set only has one label, face, I'll show you a more interesting one that has lots of data associated with it. So I'll come over here to projects. In this case, I was going on testing out some Pokemon. So in the generated features for this one, you can see here I just have 3 different Pokemon that I was labeling as well. And so it gives different color dots. What we're trying to do here is data reduction for an image that might be a high resolution to a low resolution image. And you might start seeing that there might be clusters of data of important features. So like here, these particular images are of Cyndaquil, and then you have Growlithe and Sandslash if you're familiar with your Pokemon. This can go and expand it out to lots and lots of labels. That becomes very useful for trying to see if you have any errors in your data set, things like that. So going back to our particular face detection project, I'll come back over to here, and I'll go back to this back up. After we generated the features, we need to choose our model. We have a number of different models in Edge Impulse, and we're growing that every day. We can start with mobile nets. FOMO happens to be a mobile net based model as well. And then we have a number of YOLOs in there, YOLO X, YOLO V5, things like that. You can choose different training blocks. You have multiple training blocks that you're working on at once. For developer accounts, we limit the job time for training to 20 minutes and 4 gigabytes of data or 4 hours of audio data. I could click here and start training again. It'll take a few minutes to train this particular model at 60 epochs and at a learning rate of 0.001. But this last training run tested this model on the validation set at 89.7%. And so you get a confusion matrix here, and you can see like, hey, sometimes a picture will be interpreted as a background, even though there's a face actually there. FOMO can be kind of sensitive to the distance from the camera on this particular model. And then we can see how it performed with YOLO V5. So same data set on the training output. From here, it looks like I haven't kicked off training on this one, so I'll take a few minutes. But if I remember correctly, the performance was similar, about 80% for this particular data set. Down here on model testing, I take the data that the model has never seen during training and actually run it through. And so this is important because, again, we haven't deployed on device. We're just trying to see how the model actually performs, because your model's not performing well on the cloud, it's not going to probably perform well on device. This is not terrible. It's not great. About 80% for this particular case. We can go click on a few of the particular samples and see why it may have not classified well. So we'll go and see what we're doing here is classifying the model in the cloud through that, classifying that image through the model in the cloud. And you can see that here it detected a face off in the background, even though the image only had labeled one face. But it did a really good job with the face in question. So this might necessarily not be a bad thing in this particular set of the model. Maybe we need to go and drag some more bounding boxes for these faces here in the background, as an example. But what I really want to get to today, and while we're here with Alif, is to deploy on device. So in model deployment, we've already gone through the steps of data acquisition from the device, creating an impulse, designing a model and training it, testing out to make sure it actually works. And then we're going to actually build firmware for the device and run on device. From the deployment section, we have a number of devices we can deploy this type of model to. Today, I'll choose the Alif device, and I can click on that. And then you want to choose, in order for it to run accelerated, make sure that you choose the indate or quantized model. And so this will ensure that when the model is running on the device, it doesn't run on the M55, but instead runs on the U55 model accelerator. When I click build here, it will take a few minutes to launch a compiler and eventually spit out a zip file. I built one earlier today, so I will download this from here. I'll drop it in my box, and then we're going to program on device. So I'll come over here to my Windows machine. This is where I happen to have my Alif toolkits installed, and I'll make sure I've tied my Alif device serial to it. Let me make sure I'm canceled out over here. And then I'm going to drag and drop the model that we had just downloaded into the virtual machine. So I'll grab it over here, and then I'll extract it. And then per the instructions in our documentation page, you have to do a few things. I've already downloaded the AppKit model programming software. And I'm going to drag and drop this binary over to this images page. I'm going to replace, or this images folder, and replace it for one in there. And then again, in the documentation, we have a number of commands you have to run to get the model ready to write. First of all, we're going to generate a config file. It tells us where we're going to program things, and then we'll actually write to the device. This will take a second here to open up the COM port. This particular model is kind of small, so it programs relatively quickly. All right, we have a successful program. I will disassociate from the Windows VM and come back to my Mac. And I'll launch a new terminal because that one was frozen. And edge impulse, run impulse is the command. And then --debug, this will give a webcam kind of like view on a browser page, which you can see how the model's actually running. Again, I'll choose the second device. And so what you're seeing here on the output is the output from the Edge Impulse SDK, in particular this struct. So we're trying to see what's in the frame and what kind of bounding boxes do we have. It also gives you performance of the model running on the DSP, and then as well as what is running on the NPU for the AI accelerator. It's not detecting anything because I'm not in frame, so I'm going to hold up the app kit and point at myself, so it's now doing detections. And then if we want to see a live view, we come over here to the web page, and here I am. In this case, it's detecting a face. So this is a FOMO running on device, and as we had seen in the previous slides, it's sub-millisecond, inferencing time, so you can get a lot of frames per second. And then if you want to switch to a model to a different one, it is really just as easy as choosing a new project and downloading the file and deploying it to device. So I think I can do that here in 1 second. So I'm going to choose this YOLO v5, come over here to deployment. So before I was running as well. The last time I ran was a C++ library. So instead, I've already downloaded it to my Windows VM. And we do the same kind of process as well. So I'm going to stop this, associate it over to my Windows VM so I can program it. And then I'm going to grab my person detection project. So I'll open and extract that one. Same idea, just drop it in this folder and then run the script and it will program away. YOLO v5 is definitely a larger model than FOMO. So it takes a few seconds for it to program. And while this is running, I do want to announce that we are now going to have a in-person and virtual event called Imagine. It will happen on September 27th of this year. Registration link is on this page. You can find it at edgeimpulse.com/imagine. It will redirect you to this particular Bizabo page. This is an event where we have a number of partners and speakers talking about Edge ML deployments, model application development, things like that. This list is growing by the second, and we've just launched this webpage, all-day event there in the Silicon Valley at San Jose at the Computer History Museum. And sorry, it's actually in Mountain View, not San Jose. Let's see how this programming is coming along. We're about at 76%. Remember, we're programming a bigger model now. This is a person detector for YOLO v5. All right, so I'll disassociate it here and then come back. Same command, different model, same web page to view it. Choose support. Bigger model takes a little bit longer to run. As you can see, it takes a little bit more on the DSP time, a lot more on the classification. Remember, YOLO v5 was not necessarily optimized to run on edge devices, but the Alif with the Alif device with the AI accelerator makes it run really fast. So I'll show off the web page here. I'll come over to this. And instead of detecting my face, it's trying to put a box right on top of me as a person. But same kind of process. We go to a project, we collect data, we draw bounding boxes, or we take accelerometer and microphone data. We train and classify a model, we test it, and then we run on device. And there's a number of projects that you can get started with right away, so that you don't even have to get data yourself. You can just immediately deploy a device and see how it runs. And that's about it for my presentation. Henrik, do you have anything to follow up with? Otherwise, we can take some Q&A.
No, thank you so much, Josh. As you can see, I mean, this is there are some steps kind of to go through in order to work through the Edge Impulse platform, but it really kind of is a one-stop environment for you to do all the things that you need with your training data, with your labeling, with the device deployment, and also just to be able to kind of get the simulated performance metric before you actually deploy the device. Is proving really helpful to a lot of people as they are designing and configuring their AI solutions. So I think that this is really exciting. I'm very much looking forward to seeing what people will be able to use the Ensemble devices together with Edge Impulse to create. We can certainly take some questions from the audience if anybody has any particular questions. I don't know, Luis, do you want to kind of moderate that a bit? We got some questions already on the chat.
Yeah, a couple came through the chat, and I can see you've already answered those, but I think we'll go over those again just in case people haven't seen. So Ravi has asked, can we use a more powerful camera with the app kit?
Yeah, and the app kit, we use a connector on that kit called an IAS connector. This is kind of a form factor that On Semiconductor has come up with, and a lot of module vendors that use their CMOS sensors use that connector. So any IAS camera can plug onto that connector on the kit. We also, on the other kit that we have, the dev kit that Aerostocks, we bring out all the camera connectors to pins, so you can always wrap a camera to it if it doesn't have that IES connector, but you can definitely swap out the cameras on the kits.
Great stuff. And someone noted about the accuracy here that you showed. Do we want to talk about the importance of training data?
Yes, training data is critical. We can't stress that enough. It's stressed over and over again that data is the most important thing for any kind of machine learning application, probably more so than architecture that you choose. So for this particular limited use cases, just to kind of get started so that model training times can be easily accessible for free Edge Impulse accounts, we choose training and data sets that are pretty limited, so the job times are small. And so, yeah, you don't have really good accuracy. You won't get 100% accuracy with most vision models. But we try to expose to you through the model testing, where your things can be improved, where your model might be struggling in particular, what you might be able to do to fix it. Remember too that for vision models, there's more than, in particular in object detection too, there's more than just the accuracy score. It's how well did the box center on the particular image. So you might have a highly good predictive result and say, I see a face, but the bounding box may be off center from where you were before. And so those combination of variables affect how we display accuracy numbers as well, like a COCO map score, for example.
Great stuff. Thank you very much. There's one more here that wasn't answered during the session. Is there any limitation of the ML use cases for Alif's micro MPUs that they can be used for?
I mean, there's always going to be some limitations when it comes to kind of microcontrollers versus the big cloud-based platforms. I wouldn't try to use an Ensemble device to process, super high resolution, super high frame rate video. And there's also kind of some restrictions in the ethos unit itself in terms of that quantization step that is needed. Josh mentioned that when he was going through kind of setting everything up to do the EON compilation. Ethos requires integers. It cannot be used with models that use floating point operands, for instance, for activations and things like that. So it has to be quantized. So if you're using that in your model and you want to bring that model onto an Ensemble device, that's a step that you have to go through. There's a couple of different ways that you can approach that, but it's going to depend on the framework that you use. So that's a good thing to keep in mind.
to add to that, for model development, when you do the from float training to quantization, we can do, or you can add to the code quantization aware training, right, to help bump up that accuracy. So in other words, you do another round of training, of course, it adds to your compute time and model training times. So typically, you just want to be aware of the differences between what you may run and see on a non-accelerated float kind of device if you're running that model in the computer in the cloud, and then see how that performance runs on device. And then again, there's a big step between what you see in model testing versus actual on-device deployments, which is where you want to go to actually see how your model does when you validate inferencing on device.
Thank you very much. And Henrik, I know you talked about this at the very beginning, but can you just remind people about purchasing or samples of the board and how to go about it?
Yeah, so I think I mentioned it during the presentation. Our lead global distribution partner is Aero Electronics. So go to aero.com, search for Alif Semiconductor, and you'll find links there to the boards that they stock. You can also go on our website, alifsemi.com. There's a contact us button on the website. Just give us your email address, and you can ask us questions through there, and we'll help point you in the right direction for anything that you need with regards to getting kits, getting samples, and also any kind of documentation request that you have, sample code, demo projects, etc. Would love to get in touch.
Same thing with Edge Impulse. As a premier partner with us, we do offer top-tier support for the Alif products when using with Edge Impulse. So please don't hesitate to reach out as well. We'll be happy to get you started on your ML journey.
Great stuff. Okay, that's all the questions for now. So thank you everybody for joining. And just as a reminder, this webinar will be available on demand as well. So you can go back and rewatch any of the sections if you just want more clarification or a reminder. Okay. Thank you very much, Henrik and Josh. It's been great.
Thank you so much. All right. Bye-bye.
Bye, everyone.